Welcome to today's Explainer. I'm absolutely thrilled you're joining us for what's going to be a dynamic, hands-on notebook lesson. Today we're going to decode the magic of turning raw data into perfect, easy-to-read pie charts. Whether you're a student prepping for a big math test or just someone who wants to understand all the data floating around us a little better, you are in the exact right place. So grab a notebook, maybe a protractor if you've got one handy, and let's jump right in. So, have you ever wondered how to turn a boring list of raw numbers into an actual visual story? Well, that's exactly what pie charts do. They're the ultimate tool for showing parts to whole relationships. Instead of just staring at frequencies or ratios on a page and trying to do the math in your head, pie charts let us visually compare different sectors instantly. It's basically like slicing up a massive pizza to see exactly who ate the most. Here's our roadmap for today's lesson. 1. The core concept. 2. Converting raw frequencies. 3. Working with percentages. 4. Reverse engineering charts. And 5. The final challenge. Let's start with part 1, the core concept. Think of a pie chart as a circle divided into slices, or what we call sectors, based on how your data is distributed. Each slice originates directly from the center point of the circle, creating what's known as a central angle. It's a pretty simple relationship. The bigger the share of the data, the wider that central angle becomes. This brings us to the golden rule of the lesson, and you'll definitely want to write this down. To find the degree of any slice, you take its percentage, divide it by 100, and then multiply by 360 degrees. Now, why 360? Because a full complete circle is always exactly 360 degrees. And keep in mind, all the percentages of your circular sectors combined must always add up to exactly 100%. Moving on to part 2, converting raw frequencies. Let's take some raw numbers, what we call frequencies, and convert them into our pie slices. This is a common exam question, actually. We have the contributions of 4 partners in a project, measured in thousands of LE. Ibrahim has 10, Mahmoud 11, Islam 6, and Wael 9. So how do we represent the share of each person using a pie chart? Let's break it down step by step. But hold on. Pause right here. What is the very first step we must take before calculating a single angle? Think about it for a second. We have all the parts, but what are we missing? That's right. We absolutely must find the total sum first. You just can't find a part-to-whole relationship without knowing the whole. Let's write this out step by step. Step 1, we add up our frequencies. 10 plus 11 plus 6 plus 9 equals our total amount, which is 36. Now for step 2, let's find Ibrahim's central angle. We take his specific part, which is 10, divide it by our newly found whole of 36, and multiply that fraction by the total degrees in a circle, 360. So 10 divided by 36 times 360 gives us exactly 100 degrees for his slice. Let's keep that momentum going and calculate the angles for the remaining partners. For Mahmoud, it's 11 divided by 36 times 360, giving us 110 degrees. For Islam, 6 over 36 times 360 equals a 60-degree slice. And finally, Wael is 9 over 36 times 360, leaving us with a perfect 90-degree right angle. And as a quick self-check, add them all up, 100 plus 110 plus 60 plus 90 equals exactly 360 degrees. Perfect, we know we're on the right track. Okay, let's look at this beautiful result. You can literally see how those calculated degrees translate directly into the physical slices on the chart. Mahmoud clearly has the largest slice at 110 degrees, and Wael's 90-degree slice forms that crisp, perfect right angle on the bottom right. Seeing the math turn into a visual like this is just so satisfying, isn't it? All right, part 3, working with percentages. We're leveling up the complexity now by looking at data that's already been partially converted into percentages. Here we have a student's weekly study hours broken down by subject. Arabic is 25%, mathematics is 35%, English is 15%, and social studies is 5%. But look really closely at the row for science. The percentage is completely blank. We obviously can't draw our chart if we're missing an entire slice. Now be careful here. Many students make a mistake in this step by freezing up or just trying to guess the missing number. But remember our core concept. The sum of the percentages of all circular sectors must always equal exactly 100%. So let's write out the logic to find it. Step 1. To find the missing science percentage, we take our total, 100%, and subtract the sum of all the subjects we do know. 25 plus 35 plus 15 plus 5 equals 80. 100 minus 80 means science simply must be 20%. Now we apply our golden formula from earlier to get the degrees. For math, 35 out of 100 times 360 gives a 126-degree angle. And for our newly found science slice, 20 out of 100 times 360 gives a 72-degree central angle. And there we have it, our math in action. Looking at the final study hours chart, the largest percentage, which was mathematics at 35%, correctly maps to the largest physical angle of 126 degrees. Science fits in perfectly as that 72-degree slice. You're basically translating between two languages here, from the language of percentages directly into the visual language of degrees. Next up, Part 4, Reverse Engineering Charts. Now that we've totally mastered constructing charts, let's learn how to read them backwards. Take a look at this survey graph showing the blood type distribution of a group of people. Type A is 35%, O is 32%, B is 23%, and AB is 10%. Here's the problem we're given. We are told that blood type A, which is 35% of the chart, represents exactly 2.8 million people. Our job is to figure out the total number of people surveyed, and from that, figure out how many people have type AB blood. Let's see a quick trick for reverse engineering this. Watch as we set up the algebra. Step 1. We know that 35% of the total equals 2.8 million. Step 2. To isolate the total, we simply divide $2,800,000 by the decimal form of that percentage, which is 0.35. That gives us a massive total of 8 million persons surveyed. Now, for step 3, we want to find type AB. The chart says AB is 10%. So 10%, or 0.10, multiplied by our newly found total of 8 million gives us exactly 800,000 people with type AB blood. And finally, Section 5, the final challenge. You've done absolutely fantastic work so far, but it's time for our final knowledge check to see if you've truly mastered these concepts. Here we have a pie chart showing how Sally distributes her daily calories. Dinner takes up a large 32% slice. Lunch is the biggest at 40%. Breakfast is 18%, and snacks make up the final 10%. So, here's your challenge. If we know that Sally had exactly 2,500 total calories today, how many of those calories did she consume at dinner? I want you to pause this explainer right now, grab your notebook, and use the exact skills you just learned to solve for that missing calorie count. Go ahead. I'll wait. All right, let's see how you did. We'll write out the solution step by step. Step 1, we identified the dinner slice from the chart, which is 32%. Step 2, we set up our equation. We need to find 32% of her total, which is 2,500. Step 3, we multiply 0.32 times 2,500, which equals 800 calories. If you got 800, you should definitely celebrate that. You nailed it. Congratulations, you have officially mastered pie charts. Today, we successfully decoded raw frequencies, handled tricky percentages, and even reverse-engineered massive data sets perfectly. You've seen firsthand how these circular charts can turn complex, messy numbers into a beautiful, instant visual story. But before we wrap up, I want to leave you with a slightly provocative thought. Now that you know exactly how the math is supposed to work, consider what happens when a chart doesn't follow these rules. What happens when the percentages don't actually add up to 100? Or when the angles are manipulated to look way bigger than they mathematically should be? Keep your eyes open out there, because visualizing data is a powerful tool, but knowing how to read it correctly, that's a true superpower. Thanks so much for joining.